Okay, last example for this week's homework. This is example number 2. It's like 54. Again, example number 1 goes with 47. And just a reminder that 30, 31, and 38 are just a review of finding critical numbers. So hopefully you won't need a video for those. But now, what this is going to show is there are 3 steps. You have to take the derivative, then you have to set the derivative equal to 0 and solve. That's the equation for x. That's the second part. So the first part is taking the derivative, which is the calculus. The second part is to, once you take the derivative, set that equation, that derivative equal to 0 and solve that equation using algebra. That's the second step. And then the third step is once you've established all of the x values to find the largest and smallest. As you probably have figured out by now, and throughout calculus, sometimes derivatives are easy, and sometimes derivatives are not easy. Sometimes algebra is easy, and sometimes algebra is not easy. Sometimes arithmetic is easy, and sometimes it's not easy. So in this case, if you remember in the last one, the derivative and the algebra were not bad. The thing that was annoying about the first example, the one for 47, is that finding the arithmetic, actually putting the x values into the equation and grinding out those y values, that was probably the hardest part. It's going to be kind of opposite in this one. And as you probably can imagine, is what we're headed for this is that the more we do this, the more challenging the derivatives are going to be, the more challenging the algebra is going to be. Probably not the arithmetic. That probably be most challenging with that first example. Okay, so what if we have the third root of t times the quantity 4 minus t on the interval from 0 to 8? What would the absolute max be and what would the absolute min be? Okay, so we say to ourselves, okay, the first thing I need to realize is what I need are endpoints and critical numbers. Well, I've got the endpoints. That's always going to be given to you. So I've got my endpoints. What I need is the critical numbers. So now this is where it gets a little more challenging. I'll make that t. No big deal. T is how do we find the derivative here? Now, you might be thinking that we should do a product rule, but let's not do that. We're going to need to do that, but I'm going to explain what okay. In some cases, you should do a product rule, some you should. Let's just first change this around. The third root of t, then instead of doing a product rule, distribute this in. Distribute it in. It'll be easier to take the derivative this way. Now remember, there's a 1 here, power of 1. Remember when you multiply, you add the exponents. So 1 plus a third, 1 plus a third is 1 1/3, or what we call 4/3. Now, you could do a product rule. You could do first times the derivative of the second plus second times the derivative of the first, and it would work. But that's not the easiest way to do the question. So I rewrote the equation 4t to the 1/3 minus t. So you're going to want to distribute that in to do it the easiest way. So then, again, the first step is to take the derivative. And yes, it's going to be a little annoying because of the fractions. If calculus is easy, everybody would do it. Okay, so then now what we know is what we have to do is we have to figure out when this derivative equals 0. So where will 4/3 t to the negative 2/3 minus 4/3 t to the 1/3, when will that equal 0? And then we have to factor it like we did before, and it's not too bad because it looks like the 4/3 factors out. Now this is what people have a bit of trouble is because of the fractional exponents. We've done this before, but what you have to remember is you factor out the lower power. Negative 2/3 and 1/3. We're going to factor out the negative 2/3 because it's the lower power. What that means is I factored everything out of there. I factored everything out. Remember, but there's still, you have to hold the place with a 1, of course. Now remember, if I subtract a negative 2/3, if I subtract a negative 2/3, that's actually adding 2/3. 2/3 plus 1/3 is 1. So now this is where, again, you might not notice it right away. So either t is 0 or t is 1, and that's correct. Now there's something that happened here that's important to see philosophically or mathematically. This 0 here, if I put 0 in here, because of that negative, one thing to remind yourself of, let's put that over here. T to the negative 2/3 is really 1 over t to negative 2/3, or to positive 2/3. Really, that 0 isn't making this 0, that's actually making the derivative undefined. It's actually, the graph is pointy there. But remember I said before that we have to count just zeros and we have to count undefined? So we're still going to count the 0, but it's not that the derivative is 0 there. The derivative is actually horizontal there. It's actually undefined there. But as I said before, remember we want to count it anyways. So sometimes people look at that and they go, well, Mr. Peters, why is it undefined? Because of the negative exponent. It's actually downstairs. That means when we put the 0 in, we're actually multiplying by 1 over 0, which is actually undefined. But the good part is it really doesn't matter. Now, this brings up a couple of other things that you might not have, we haven't come across. Notice we get 0 twice. This one goes away. This 0 goes away. Now, it doesn't matter which 0 you actually throw away. Could you cross the other 0 out? Or you probably realize it really doesn't matter at all. But why is it the critical number? Because remember, the critical number has to be inside the interval. 0 is not inside the interval, it's an endpoint. It's an endpoint, not a critical number. Does that matter? No, but just don't do it twice because there's no point in it. Okay, so I've got to check 0, and I've got to check 8, and I've got to check 1. Now this is, notice that the first step, taking the derivative, a little bit trickier, and then solving a little bit trickier. So notice that the work's getting a little more challenging in 54 than it might be in 47. So now when I put 0 in, I get 0, because 0 to any power is 0. 0, 4 minus 0. I know I'm being silly. I get 0 times 4, which is 0. So the endpoint is going to be at 0, 0. Then I put 8 in. Now you have to know the third root of 8 is 2. 4 minus 8. 2. 4 minus 8 is negative 4. So you get negative 8. So if I put 8 in, and again, notice this calculation a little trickier than last time. Well, maybe not. It's a little different than last time. Notice that this 0 is not a critical number because it was an endpoint. So just don't worry about it, and then put 1 in. Now, one good thing is 1 to any power is 1. 4 minus 1 is 3. So 4 minus 1 is 3. So 1, 3. So we get 0, negative 8, and 3. Remember, at this point, then it becomes just literally, that's the smallest, and that's the big one. So what we're going to say is the absolute max is 3, and the absolute min is negative 8. So, and again, like I said, sometimes we write it like this. 1, and sometimes, and I'm only doing this because the textbook does this. So there is an example of one like 54. And again, what we're doing is find the absolute max and the absolute min using this algebraic method. We take the derivative of the equation, then we set that derivative equal to 0, and we solve, and then we get what's called the critical numbers. We add that to the list of our endpoints. Then once we do that, we put them into the original equation. Then we know that the biggest number, in this case 3, is the max, and then the smallest number, negative 8, is the min. Okay, again, we're going to keep doing this next week. I'm going to give you another homework assignment where we have to find absolute max and min. for 3 more questions, and then we're going to start doing the word problems after that. Okay, thank you.